Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Science Thursday, we're gonna talk about electric vehicle charging. So let's dive right into it. Well, first you have to understand electric cars are basically battery banks on wheels. That's all you have to understand about it. Now, be mindful, each car have a different kind of a scope, as in like the how big its battery bank is, and that will define how quickly or slowly you can charge that puppy. For example, there is one electric car that is very popular in India, that is Mahindra E20 Evo basically, and this puppy has battery bank in the largest size 15 kilowatt hour. Then there is a new one that is supposed to be coming around March 2021, that is Tata Nexon EV, and that puppy is like more like a SUV rather than a light car, so it's around 30 kilowatt hour. Now then during March also Tesla Model 3 should also come into India, and that puppy should have 82 kilowatt hour of battery bank. Now if you want to charge all these things in 1 hour, you can easily guess like, hey, you need to draw 15 kilowatt from the transformer, you need to draw 30 kilowatt, you need to draw 82 kilowatt. So if you do not have basically a grid system that can support these loads, do not expect your car to charge under 1 hour. That's like bare minimum. That's the easiest way to figure out how quickly you can charge that. And for normal home residential use, 15 kilowatt power draw is a lot, so don't even think about 30 kilowatt. Now let's understand the basic level. This is like a basic stuff that every electric car company includes. It is also a safety kind of feature, is that there is a simple solution. They're just gonna give you something that you can plug in directly, basically directly plug it into any plug socket, whatever have you. Now be mindful, because of the huge battery size involved in cars, these are barely powerful enough to charge your car efficiently enough. So they call it trickle charging. What does that mean? That simply means even if you wait overnight, you will barely have few percent charge added. Now that's acceptable for people who have very short journeys. Basically, let's say you charge your car for 100%. It could take as long as like 3 to 4 days if you want to do on this, and hope you don't have power cut in between. That then, and if you are only driving, let's say 10 kilometer, and it takes, and you can plug your car in overnight, it can easily add basically 10 kilometer of range per night. Then you are okay with that, and this does have advantage. Your battery will live ludicrously long if you use this. So that's one thing is there. However, charger, this puppy is not charger. Whatever you see in your wall, this box, these are not charger. All it is just a adapter, quote unquote, because it's have to adapt this fancy connector to your normal AC wall system. Now these things are generally, in case of India, limited to 15 ampere. Basically it cannot draw more than 3 kilowatt, like around 3 kilowatt. Some cars do push it a little bit, but it does end up in a risky scenario where if your plug is not wired properly, does not have a right gauge of wire, it could trigger, if you're lucky, it could trigger a basically circuit breaker. If you're unlucky, it can set your house on fire. So be very mindful about that. And these things are just given as a last resort, not as your first option. And if you're serious about it, like utilizing even this level 1 charging, every car manufacturer is gonna ask you, hey, can you install a basically charge point. The benefit of charge point, it has multiple layers of safety and security built into it. For example, it can detect whether there is a ground fault or not, is there basically how many amperes is drawing or not, temperature system, like it has just safety functions built into it, so you cannot just accidentally set your whole apartment complex on fire. So that's the level 1 charging, last resort, and only usable if you have very low driving range and your car is fairly small, like around Evo 15 kilowatt hour. So some people have successfully managed to utilize their car effectively, comfortably utilizing this only, and that I can guarantee you the battery cells are like, I'm relaxing, man. So this is level 1, last resort. Then we come to level 2. Now this is the most practical one. Now this puppy can range in ludicrous power range. So it could start as low as like 50 kilowatts and go as high as 350 kilowatt. So you can understand that this puppy can charge most cars under 1 hour. Now there is one thing you have to understand, because you are talking about this large amount of power, there needs to be a handshake. Thankfully, this is an AC system. That means the charger is still in your car. So your car, the charger that is built into your car is the best kind of charger for that battery bank. It's fine-tuned for each other. So there has to be a handshake. Now, what does that mean? That simply means while this plug point could have 3 phase of fire, like it can have 1, it could have 2 in USA, it could have 3, European Union, India, Australia, things of that nature. It will generally have 3 systems. So what this puppy has is a contactor, and contactor has like a bit of a communication IC built into it, and that IC is gonna communicate with your car and it's gonna talk to it. It's like, bro, understand this, I can only supply you, let's say 5 ampere on each of my lines, you have to accept that. And whoever designed the basically inverter charger controller for your car, they will be like, okay, 5 ampere is the requirement, okay, set 5 ampere on each line. Or if it was like, let's say, a bit more industrially well built system, and it's like, hey, I can accept 10 basically 10 ampere, it's like, okay, I'm gonna set it to 10. Now what happens if other charge exceeds that? Let's say your plug is designed for, let's say it's an industrial plug, it's designed for 350 kilowatt. Again, because the charge controller is in this car, it's not gonna draw power, it's just gonna be like, oh, you can go to that high, and my maximum, let's say the highest ampere this puppy can provide, let's say, is 50 amperes. Is like, bro, I only need 10 ampere at super maximum. Each of these lines, it's like, it's just gonna go at full power. So be mindful, that's why this is there. It's just a contactor to protect you in case of overload. Basically this will not allow overloading. That's the whole point of this puppy. It's gonna talk to it. It's like, bro, you can only draw 5 amp, bro, you can only draw 6 amp power. And if everything matches perfectly, it does not even need that. But be mindful, this is a safety device. It also has a lot of feature where it will disconnect the power the moment you press a button on the basically handle. It's gonna know that you're gonna disconnect it. It drops this contactor, so you don't have electrical arcing on the plug side, so your plugs last much longer. Or there are some other also contactor built into it. So if you go into your car and this puppy is still connected in, you will not be able to shift your car into basically driving. It will still stay stuck in parking. So this is level 2, and charger is in your car. Now be mindful, in some basically some car companies you will have option of inbuilt charger. Now if you are utilizing on level 2, pay attention to that, because they will specify it has like 10 kilowatt hour charger, or it has 20 kilowatt hour charger. Again, depending on your need, if you drive a lot and you utilize level 2 chargers a lot, you may want to invest in extra to get that higher charger, because these are nothing, these are just a contactor. It's just gonna be a like safety device where it's like, do not draw more than this. So that's what you have to understand. This is level 2. This is what's most commonly used, and it has more than enough power if done correctly. If you have your home ampere circuit can provide the load required for this puppy, it can charge your car easily under an hour. So this is level 2, most common, most easily used system. Then we come to DC fast charging. Now this puppy is a whole another level, because you are bypassing the charger that is built into your car. It's like you took the car charger and it's like, nope. So it requires handshake, because you are directly connecting to the battery itself. It has failsafe on top of failsafe on top of failsafe, because if something bad happens, you will literally set your car on fire. And heck, it won't even be a fire, it will be a big boom event. So be very mindful about this. And the handshake is simply is there because charger is in the station. So that station is connected to very high load lines from a grid. Basically it's connected to a transformer which has large enough VA rating. It is connected with cable that can handle like 100 of amperes of load, and this converts that GG amount of power into DC power. Now because it has handshake, it's directly gonna talk to the system. So for example, let's say in Mahindra Evo, it's gonna talk to it. It's just like, bro, how much do you need? It's gonna say, hey, I need around 80 volts of power. It's like, awesome, I got it. How many ampere you can handle? It's like battery bank is gonna say, hey, I think I can easily handle 100 amp hour. So it's gonna dump that kind of power directly into your battery, bypassing the charger. Now why the heck you have to bypass the charger? Simple. If you put any electrical equipment that can handle 100 amperes of electrical load, yeah, that would be huge. It will literally be like adding almost like 4 or 5 seats in your car. That's why, like, to make sure your car mileage is good enough, people don't do that, simply because it will be very big. Like you can see that, like, this is a huge thing. It's not just a contactor, it's a huge power inverter circuitry. So to make sure this weight is not added into your car, it's like it's put outside. Now this puppy has the luxury of charging your car under 30 minutes, because it's directly communicating to directly contacting the battery. It can directly do that. Now be mindful, there are still standard on this puppy is not standardized. So right now it's like 300 volts. That's how high it can go. Now for future generation, people are trying to put this substandard inside it, where it will go as high as 500 or 1000 volt, especially for buses. So that will allow to dump a lot more voltage. And then there is the biggest aspect of it. It is very expensive, and you have to understand this aspect. The cable they require, like most time people have no idea how thick these cables are, because again, we don't handle cable in our day-to-day life that is like built for 100 amperes of electrical load. And then for companies were developing a standard, they actually realized, hey, what if we use a thinner cable so people can actually move it, and then cover that puppy up in oil to basically cool that. Basically how we cool our transformers. It's like, that's how much electrical load is in there. Like that's one thing you do not think about, but it has to be manageable. Like it has to be like, so this is the DC fast charging. The charger is outside your car. All it's gonna do is talk to your battery bank, and it's like, how much can you handle? It's like the highest your car battery can accept. It's just gonna pour that puppy in. Now, be very mindful that because of this ludicrously expensive equipment is not something suitable for home users, like unless you are ludicrously rich, and it's also very large drain on the grid also, because power grids, you are charging everything in like less than 1 hour time. So basically 100, for example, 100 watt hour battery bank, if you want to charge it in 30 minutes, that's like 200 kilowatt hour kind of load on a transformer. So transformer has to have around, you're talking about DC circuit, so it's very inefficient. So 250 VA rating, kilovolt rating it has to have. That's a very expensive transformer. So be very mindful. DC fast charging is not suitable for most scenarios, and it's also very stressful for your batteries, because batteries can easily accept from 0 to 80. It's like, bro, I got this, give me power. The moment it exceeds 80, it's like, bro, relax, calm down, reduce the voltage. And you will see that like every charge, basically car manufacturers, like 0 to 80 in a few minutes, and 0 to 100, why the heck there is no 0 to 100? It's like, because from that 80 to last 100%, it will take twice as long, simply because the batteries are basically an insulator. They are a chemical powder, they are insulator inherently, so they heat up, and that heat takes much longer to dissipate. Now in older cars, they did not had any cooling circuit, so that was a much bigger limitation. Nowadays, even though they have cooling, it's like bit better, it's not too much better, because again, the cell itself is like acting like an insulator, and that's why so many people are excited about Tesla's tabless battery, because that has much better thermal conductivity, so you can pump a lot of power into it without cooking it. So that's DC fast charging. You are bypassing the car's puny charger, and it's like, I'm going to give you GG charger, and that charger will only be limited by how fast your battery bank can absorb power. And that then this is the only sensible way to exceed, basically charge under 1 hour. Now, what we can expect in the future about this technology? Now, you have to understand that we have to make a global standard. We cannot, every company was acting like Tesla before, everybody was making their own stuff, so it did not work out. Nobody succeeded in that kind of scenario. But thankfully, after a lot of trial and error, people standardized on CCS2. Now, CCS2 is like built with a lot of learning experience. So what they have is an AC unit. Now, this unit will absorb one phase power. So if you are like basic bitch power, it's gonna like handle it. You have a level 2 power where you have 3 active lines, it can still handle that. And what if you want to talk about DC? These are the 2 giant barrel jacks. They are specifically designed for DC also. So this one plug in your car can accept AC and DC, and the charging system is designed in such a way that your this connection will no longer be a limiting factor. In older connection, there was a serious limitation. It's like it could not dump enough power. The plug was not designed for high enough ampere. This time they learned a lot of lesson. It has more than enough fail safe, it has more than enough capacity, and people are trying to put like a 500 volt. Now be mindful, they can only put 500 volt if the battery bank is 500 volt, because you cannot have a basically converter circuit anymore. So you have to have battery bank voltage has to go up, which is a very double-edged kind of sword. Do you really want to sit on top of something that is like 500 volt DC? Yeah, that's a very big oops. So thankfully, that CCS2 structure is standardizing AC and DC, and it's same everywhere. European Union, USA, India, Australia, almost everywhere on the planet is trying to be standardized. Now, grid need at this point in time, most of the people will be satisfied with level 2, and that's okay. That's how it's supposed to be. You're not supposed to like think basically how you think of a petrol car. Like our petrol car logic is like, I drive a car and I park it somewhere and I fuel it with fuel. That's not how electric car is supposed to be used. A way electric car is supposed to be used is like, you utilize the whole day, and during the time when you're sleeping, you're supposed to charge it easily. So that will also make your battery live longer. So why the heck do you want to compromise the life of your battery bank? So that's why level 2 is awesome, and level 2 does not require too much load on the basically transformer grid. So rather than every basically block needs to retransformerize just to provide a super fast charger. So level 2 is awesome. Now DC fast trip is only usable if you're doing long drive. If you're like, that's all you do, is like, I go into long drives and I drive for like 600 kilometers or 800 kilometers or 900 kilometers, then you need DC fast charging next to your highway. That's what you need to do. But other than that, most times level 2 is more than good enough. You don't even need to shorten your battery's lifespan by utilizing these things. And that's why basically there was a kind of a quote-unquote a scam kind of scenario happened with a Tesla, where they're like the person bought basically Tesla, and they were speed charging that, and it was like boom, full charging very quickly. And then they're like randomly noticing after like doing that few times, it's like, wait, why the heck it's not charging anymore? Is the computer software was detecting that the battery was degrading too quickly. So like, bro, calm down. DC fast charging looks good, sounds awesome, but it's very bad for both parties involved. Basically, your grid is like, what the hell you are trying to do to me, and your battery is like, what the hell you are trying to do to me. So in future, most people would be very comfortable with level 2 charging. Basically DC charging will only be needed for long drives, and that's the future. And if every company is standardized, it will be far more practical, efficient, and widely adopted. Because if we can't even figure it out, you don't expect EV to ever take over. Like if we can't standardize this, like think of it this way: do you ever think which basically petrol nozzle you have to use? Like we have not even standardized these things yet. So that's the reason why EVs are not picking up yet also. So this was my presentation on EV charging infrastructure. I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment because I try to reply to all of them. Subscribe, press the bell icon to feel free. And as always, thanks for watching.